All right, so I need you to know that we have already covered this, and we are here right now. Excuse me. Now, let's start with a pure resistive circuit. All right, so I just need you to take note of P naught, maximum power. You can as well call it P max. All right, and then average power. These are just the two that I need you to take note of. Okay, now maximum power is equal to the peak current times the peak voltage. All right, now you can as well write it in terms of the RMS value. So if I remember that peak is RMS value times root 2. Do you remember? Peak current is this, then times peak voltage will be RMS value times root 2. So that if I multiply out, I will have 2 times I hope that is clear. So root 2 times root 2 will give us 2, or root 4, which is 2, all right? And then you get this. So take note of this, and then take note of this. So that is for peak or maximum power. Now, when you come to average power, some people call it true power. You can as well call it the active power, okay, and wattage. Now, this is not to take us to power triangle. Some of you, even though this is above your scope, so using the power triangle, we have the active power here, we have the reactive, and then we have the apparent power. And here you have your file, the phase angle. And even though I've not talked about power factor, from this triangle now, power factor will give you active power over apparent, okay, power. Can you see that? Adjacent over hypotenuse. But this is, I think it's above your scope, all right? So let's just focus on these two, maximum power and average power. Is that okay? So average power is equal to the RMS value of the current times the RMS value of the voltage, like that. All right, you don't need to consider cos file, even though I'm going to be telling you the formula for cos file till we get to a combined circuit. So like this, remember you can as well write it in terms of the peak value. So if I know that RMS value of the current is the same thing as peak over root 2 times this one is peak over root 2, then that means we'll have peak times peak voltage divided by 2. I hope that is clear. Okay. Now, if I write it like this, you notice something here, because we want to answer this question. Look at this question. It says prove that maximum power or peak power is equal to 2 times average power. Can you see it from here? So if I have average power is equal to what we just got now. So, all right. So I now know that this one on above, can you see it here? This is peak power divided by 2. So if I cross multiply, of course, it becomes obvious that average power, or you say peak, rather, peak power is equal to 2 times average power. I hope this is clear. All right. Okay, so when it comes to a combined circuit, okay, the same thing, average power, it's equal to current times voltage, but it has to be the RMS values, okay? And then cos phi, okay? Now, cos phi stands for power factor. So cos phi is power factor. All right. Now you can as well write this in terms of the peak, but let me give you the second formula. So average power is also, if you want to write it in terms of current and resistance, so it, of course, I squared, but it's RMS value times R. So these two formulas, I need you to take note of them. That doesn't mean that we cannot rewrite this. We can as well have, remember what this is. Okay, so that you will have what? All right, so it's still the same thing. So take note of this, these two formulas, basically. Now, what is power factor? Watch now. Let's start here. Show that power factor is R over Z. Now, did you remember the triangle we drew before in our last video? Okay, let me redraw it. You have like this. Okay, so this is our file, and then we had VZ here. Do you remember? VL minus VC, and then here we have VR. Now we can as well rewrite this, or redraw rather. It will be like this. Here is Z, here is R, and here is XL minus XC. Do you remember? All right, so using this triangle now, cos phi will be what? Adjacent over hypotenuse. You remember? So that means power factor, which is cos phi, is R, adjacent all over the impedance rather. Okay, so this is the formula for power factor. Is that okay? Now, this question here says, if phase angle is 0, maximum power will be obtained in an RLC series circuit, true or false? So let's find out. So if the phase angle is 0, so watch, phase angle is 0. That means cos 0 will be equal to what? 1. Punch it, you see that it is 1. So because it is 1, this whole equation here, this one, okay, average power will now become what? Just I times V. All right, because cos phi, it's now 1, and 1 multiplied by everything here will give us the same thing. So the power, the average power will be maximum. But if the phase angle is 90, whether angle of lead or lag, all right, that means cos 90 will give us 0. And that means everything here will become 0. So average power will become 0. Did you get that? All right, before we talk about energy stored or energy dissipated, I need you to know that power is dissipated here. Power is not dissipated in a capacitor. All right, so over half a cycle, it is you have energy stored. Over the remaining cycle, you have the energy released. So power is not dissipated here. Power is not dissipated here. This is pure reactance, of course. Power is not dissipated here. So power here, even the power that is dissipated is only here. It has no business with this guy. Only here. It has no business with this guy. So power is dissipated here. Power is dissipated here. Is that okay? So power through an inductor or a capacitor is 0. I hope you know that. Okay, so let's look at these two questions. When an AC given by this passing through a 12 ohm resistor, the power dissipated in the resistor is what? Okay, so now we are given that the resistance value is 12 ohms. Okay, now I can see from the equation that the peak value of the current is 10 amperes. Okay, now I know that average power is equal to I squared R. Okay, so that means I need to convert this guy to the RMS value. So RMS value of the current is the peak divided by root 2. Do you remember? So this will be 10 over root 2. So that means average power is equal to 10 over root 2 squared times the resistance, which is 12. Okay, so this will give us 100 over root 4. You remember? Okay, and of course times 12. So we have 2 here. So we have 100 over 2 times 12. All right, so the correct option is D. Is that okay? All right, so what about here? The power factors of a pure inductive, pure resistive, and pure capacitive respectively are what? So I need you to know that for a pure inductive circuit, we have the angle of lag. Remember that current is lagging behind voltage. So the angle of lag is 90 degrees. That means power factor cos 90 will give us 0. Okay? All right. So what about a pure resistive circuit? So for a pure resistive circuit, the phase angle is 0. Therefore, power factor cos 0 will give us 1. All right? So you take note of that. And then for a pure capacitive circuit, phase angle, the angle of lead now is also 90 degrees. Therefore, cos 90 is going to give us 0. So we have 0, 1, 0. Okay, so what have you noticed? Now, the power factor for a pure inductive circuit is 0. Okay? Power factor for a pure capacitive circuit is 0. Power factor for a pure resistive circuit is 1. Don't forget that. So power factor ranges between 0 and 1. Is that okay? Alright, finally, let's talk about energy stored. So energy can either be stored or dissipated. Is that okay? So stored in a capacitor and an inductor. We saw that when we learned DC. But remember that we are talking about AC here, right? So whereas energy is only dissipated in the resistor. Is that okay? All right, so let's start with energy dissipated. So energy dissipated through the resistor will be equal to I squared RT. That's the RMS value. Just like this. Is that okay? Okay, now in DC, you remember the energy stored in a capacitor. For instance, energy stored in a capacitor is half CV squared. Do you remember? That's for DC. But actually in AC, the average energy stored in a capacitor over one cycle is actually 0. That means energy is not really stored in the capacitor. That's with respect to AC. Okay, so over half a cycle it is stored. Over the remaining cycle, all right, it is released. So it's not actually stored. But you can talk in terms of the maximum energy. That's E naught or E max. All right, when you have a combined circuit, take a look at this. So the maximum energy stored is half CV, but listen, is peak here. All right, you can as well write it in terms of the root mean squared value. Remember, so half C, and then here you have root mean squared value. That's peak is equal to V RMS times root 2, okay, squared like that, so that you will end up having, if you tidy it up, it will give you C V squared. So the 2, these 2 will cancel the 2 here, all right? Root 2 squared is 2, so it will cancel, and then you have this. Okay, so you can either write it like this or you write it like this. Now, same goes for an inductor, all right? So the energy stored in an inductor over one cycle is 0, but the maximum energy, okay, is this, all right? So half times the inductance times peak current squared. All right, so let's answer this question. Calculate the amount of heat generated in an external load of resistance this if an AC of peak value 5 ampere is passed through. Okay, so we are given that the peak current is 5 amperes, right? And we are given that R is 8 ohms. And then time, T is what? 100 seconds. All right, so we just plug in our values. Heat, which is a form of energy, remember, heat energy, okay? So energy is I squared the RMS, all right? Then R times T. So let's plug in what we have. But here we have the peak value. So the RMS value will be the peak value, okay, which is this 5 divided by root 2. Is that okay? So we have 5 divided by root 2 squared times 8 times 100. So if you punch this, you should get 25 over 2 times 8 times 100. Okay, so that 2 here is 4. And then we have 25 times 4 is 100. 100 times 100 will give us 10,000. All right. And this will be 1 times 10 raised to the power 4. Okay, remember it's joule. The unit of energy is joule. So the correct option is B. All right.